Modern quantitative trading is defined by friction. When a market shifts, an institutional pod has fractions of a second to react. For these funds, moving assets out of secure cold storage and into a live Layer 1 decentralized exchange creates a massive bottleneck. The culprit is the standard architecture of Web3 itself. Reliance on traditional JSON RPC routing and multi-signature approvals acts as a structural roadblock. This system imposes a latency tax and takes upwards of 200 milliseconds just to route and sign a single transaction. In high-frequency environments, 200 milliseconds is an eternity. By the time that data packet reaches its final destination, the mathematical edge decays to zero. For an autonomous risk strategy that wakes up every minute to check its thesis, arriving late to a volatile liquidity pool means getting flattened by faster actors. Standard custody solutions operate as a structural barrier, limiting capital mobility at the exact moment it is required for execution. ONO OS.wallet is a technical countermeasure. The interface is a stark, telemetry-driven command center built for the specific requirements of institutional allocators. It achieves sub-millisecond execution by bypassing standard JSON RPC web routing. The ONO protocol establishes direct cryptographic tethers using subkeys tied to exchange matching engines. This architecture collapses transaction times from 200 milliseconds down to single-digit milliseconds. The sizing screen functions as a precision instrument, allowing an allocator to inject quantified risk into the market with a single tap. By solving the latency equation, ONO OS functions as a direct execution gateway for institutional capital. Speed requires analytical control. Rapid execution without institutional-grade risk management is simply a faster way to lose capital. The wallet's backend manages risk autonomously based on 120-hour realized volatility, a metric often cited as the Mandelbrodian edge. The system calculates this data block to categorize the market into three states: low, transition, and high volatility. In the low-volatility Joseph regime, the system suppresses trade sizing to protect capital from market noise and static environments. A high-volatility breakout triggers the Noah regime. The system automatically doubles trade sizing and adjusts leverage to maximize exposure to the move. This level of autonomous protection, typically restricted to $500 million plus AUM pods, is here integrated directly into the wallet backend. These capabilities bifurcate the workflow. One agent acts as the brain, monitoring intelligence streams, while a second agent acts as the sniper, executing trades on the matching engine. This is an agentic-as-a-service platform. It provides funds with a deployable software workforce that manages the entire lifecycle of a trade. This architecture allows senior pod managers to bridge the gap between cold storage security and immediate execution. In markets where alpha is captured in milliseconds, minimizing network delay and human friction is a prerequisite for executing high-frequency strategies. By combining the ONO protocol with autonomous volatility regimes, the ONO OS.wallet provides capital mobility at the speed of computation. This is the new architecture of profitability.